Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. Up to now, we've spent a lot of time defining derivatives, using limits, tangent lines, and careful logic. Today, things change. Instead of computing derivatives from scratch every single time, we're going to introduce a set of rules that let us find derivatives almost instantly, at least for a very important class of functions. Now, before we get started, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. The functions that we're going to be looking at today are going to be polynomials, powers of x, and exponential and logarithmic functions. This is where calculus starts to move fast. So let's jump into our very first rule, which is the power rule. And this is the most important differentiation rule you're going to learn early on. The power rule says that if our function f of x is equal to x to the power of n, where n is some number, then the derivative of f of x, which is f prime of x, is equal to n times x to the power of n minus 1. So essentially, that means the exponent, n, drops down to the front so that it becomes the coefficient, and then the new exponent is now 1 less than what it was before. And we've seen this a few times before in our limit videos. We will aim to prove this rule in a future video, but for now we're going to take it as a fact. So let's take a look at how to use this rule through a couple of examples. Our first function is f of x is equal to x to the power of 5. So to differentiate it, that's going to be f prime of x, and then the power rule tells us that we can pull the exponent down to the front, so that means it's now going to have a coefficient of 5. And then we will have x to the power of, and the power is now going to reduce by 1. So meaning it's going to be 5 minus 1, which is 4. So f prime of x here is going to be 5 times x to the power of 4. For our next example, we have a polynomial, but we can actually just apply the power rule to each term individually. So that means g prime of x is equal to, now when we were doing the derivatives using the limit law, we know that for a coefficient, we can just pull it out to the front. So we're going to leave the 3 as is, and then we're going to take the derivative of x to the power of 4. So that means we're going to pull our power down to the front, so that would be a 4. And then this is now going to multiply by x to the power of, reducing the power by 1 is going to give us a power of 3. So this would be the derivative of that very first term. And now we're going to move on to the second term, so that's going to be minus, and same thing, we're going to leave the 7 in the front, take the derivative of x squared, so that is going to be 2 times x to the power of 1. So this one is going to be the derivative of the second term, that is right over here. And now the last term is 9. And we know that the derivative of a constant is just 0, so that would be plus 0. So cleaning this up a little bit is going to give us g prime of x is equal to 12x to the power of 3 minus 14x. For our third example, we're asked to find the derivative of 1 over x to the power of 3. So in order to use the power rule here, we need to rewrite the expression 1 over x to the power of 3 in the form of x to the power of n. And our exponent rules tell us that whenever we have an exponent in the denominator, that is the same as just having a negative exponent. So this is really just us taking the derivative of x to the power of negative 3. And now we can go ahead and use our power rule. So we're going to peel that exponent to the front, so that'll be negative 3. And then we multiply this by x to the power of, and we reduce that power by 1. So negative 3 minus 1 is going to be negative 4. So the derivative of 1 over x cubed is negative 3 times x to the power of negative 4. And now our last example is y is equal to the square root of x. So again, we're going to rewrite this radical in the form of x to the power of n. Now our exponent law here tells us that the square root of x is x to the power of 1 over 2. So therefore, y prime is going to be equal to, peeling that power down to the front, so that'll be 1/2, and then reducing the power by 1 means we're going to have 1/2 minus 1. So this is going to be x to the power of negative 1 over 2. So we can see here that n doesn't need to be an integer. As long as we can rewrite the expression into the form x to the power of n, we can use the power rule. So a couple of the other derivative rules that we're going to be using throughout this playlist are the exponent rule and the natural log rule. We have the derivative of e to the x is just itself, so it's still e to the x. And the derivative of the natural log of x, so ln of x, is equal to 1 over x. And again, for now, we're just going to take these two as facts. So for our last example of this video, we're going to combine them all together. To differentiate f of x here, again, we're going to do it term by term. So f prime of x is equal to, our constant 5 stays in the front, and the derivative of ln of x is equal to 1 over x. Now the second term is the cubic root of x to the power of 5. Rewriting this as a power of x is going to be x to the power of 5 over 3, which means using the power rule to take the derivative of that, we're going to get 5 over 3 times x to the power of 2 over 3. And then the last term here is 4 times e to the x, so that's going to be 4 times the derivative of e to the x, which is still e to the x. So therefore, our answer for this question is f prime of x is equal to 5 over x minus 5 over 3 times x to the power of 2 over 3 plus 4 times e to the x. And feel free to just leave your answer as a fractional exponent. You don't need to change it back to radical form. And now let's do a quick recap of what we covered in this video. We went over the power rule, which said that the derivative of x to the power of n is n times x to the power of n minus 1. And we saw that this works for negative as well as fractional exponents. So make sure you're familiar with all your exponent laws because they're going to come in handy here. We saw in our example that if our expression had multiple different terms that involved x to the power of n, we can differentiate term by term. But note, this only works when you're adding and subtracting those terms, not when you're multiplying and dividing. We're going to be covering what happens when there's multiplication and division in a future video. We also went over a couple of other important rules, which are derivative of e to the x and the derivative of ln of x. And now it is your turn to give this a try. Can you find the derivative of f of x shown on the screen here? Make sure to leave your answer in the comments below and let us know what other calculus topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.